Hello everybody, I'm Todros Kide. Welcome to my series video. Today I will present about the classification of clutch system. If you remember last time we will try to see about the second chapter first video, which is concerned on overview of clutch system and clutch system construction. So today we will emphasize on classification of clutch system. In this part, we will try to see types of clutch discs, types of pressure plate assembly, and its impact, classification of clutch system, or classification of clutches, and clutch operation will be covered. In the first part, we will try to see about the clutch disc, which is solid drive and cushion drive, and in the next part, types of pressure plate assembly according to the upcoming force or clamping force. Which is diaphragm type and coil spring type pressure plate assembly. And in the classification of clutch, we will try to classify by different mechanism, by the friction surface they use, by the friction type drive or weight, and also by different mechanism, like we can classify in positive clutch, and by number of discs also we can classify single, multiple. So we will go through in this part today. In the first part, when you see the types of clutch disc, we will have two types. The first one is as you observe in the left side, we call this one solid drive, and the second one we call cushion drive. Here what difference is come from these types of clutch disc. As you know, this clutch disc is intermediate component between the pressure plate assembly and the flywheel, which is sandwiched in its location in between. So which means when it transfers the power from engine to flywheel, sometimes it will transfer also some torsional vibrations. To prevent that, in the first old version clutches, they didn't have any mechanism like torsional spring here. So in this part, the difference is came from here. So this will have torsional spring, and this will not have any torsional spring. So the torsional vibration or the torsional vibration will be automatically transferred to the engine, from the engine to the gearbox, or from the gearbox to the engine. Mostly it comes from the engine. And the next one is it will have also cushion, as the name indicates, cushion drive. So that means it will have allowed a limited angular movement. At the same time, in between it will have some spiral cushion springs. It will have some cushion spring, it seems as the next one is the pressure plate assembly. Pressure plate is also called the clutch cover or clutch assembly because it's composed of different parts: the springs, the diaphragm, the diaphragm or the coil spring. Also, it will have some parts like the frictional surface area. So that's why we call clutch cover assembly. The cover assembly is mostly bolted on the flywheel, and it rotates together always. We will have two basic type of pressure plate assembly. This type is come from the force that is exerted to create or clamping force. That means the clamping force is come from the pressure plate assembly because the flywheel doesn't move back and forth. Only the pressure plate frictional surface will go back and forth to create some clamping force, and that clamping force is come from in this case it will come from the multi-coil spring, and in the diaphragm type it will have diaphragm spring. In most cases this multiple coil spring type use coil spring release levers, and it exerts force around 3000 to 1000 for light duty and heavy duty vehicles. And it mostly used in heavy duty vehicle by different reasons, because by increasing the number of springs we can increase the clamping force. That's why it's preferable for heavy duty vehicles. Also the diaphragm spring pressure plate type we'll have the clutch spring we call diaphragm spring. That's why the name says diaphragm spring type pressure plate assembly. And the shape also, it seems diaphragm. Then the spring compress in annual disc initially to energize the spring. They will make in conical shape form. So when it dish in and out, it will have stored energy, because if the spring have initially stored energy, it cannot create clamping force. Sorry. If you see this both types, this one is the coil spring type clutch, and this one is the diaphragm spring type clutch. So the difference is came from it uses this spring for creating clamping force, and this one uses this diaphragm spring to create clamping force. So for this type, if we increase this number of spring, the clamping force will be increased. That's why it's preferable for heavy duty, and mostly we will get this one in light duty and in some heavy duty vehicles. When we come to the advantage and disadvantage of this multi-coil spring pressure plate and diaphragm spring pressure plate, if we consider the clamping force, the clamping pressure is increased with the number of springs and their tension. That means if we increase these springs, the number, maybe the tension, the clamping force also increase. So simply for these types of clutch to increase, for example, light duty vehicle, heavy duty vehicle, machineries, they require us to transmit high amount of torque from the engine to the gearbox. So they requires at the same time high amount of clamping force. That's why it need to have additional or high tension springs. Again, putting a weight at the end of the release lever results in centrifugal force apply the clutch more tightly at higher speed. If you see this one, in this part of types of spring, they will put heavy weight in the cover part. That's why when the centrifugal force increases, this weight will push down the springs toward this or against the flywheel. So that means when it pushes too much, the spring force will increase and the clamping force increase. That means it allows this type of spring to transmit high amount of torque at high speed. So when the speed varies, the torque transmission rate of coil spring type clutch will be vary. They require more pedal effort than the diaphragm pressure plate. We will see later this one by means of graph, because when we compress the spring also will create some reaction force. That's why it will create additional force. And as the clutch disc wear, this will be the disadvantage for this part. As the clutch disc wear, the coil spring will become expand or release, so the stored energy will be released and the clamping force will reduce. So there will be slippage on these types of clutches. In diaphragm spring pressure plate, they will have higher load carrying capacity when we compare with the weight and the load transmitting ratio. That means they are lighter construction. By light material, we can transfer high amount of torque or load by means of friction. That's why they are preferable for light duty vehicle. And the clutch pedal effort will be reduced when we depress the clutch pedal. I will show you the reason. This one, because when the driver depress, the shape of the diaphragm will be straight. At that time, the force will be reduced. And the torque transmitting ability also less affected by high engine speed, unlikely the coil spring. If you remember, the coil spring at high speed, it will transfer higher RPM, high torque. At lower RPM, the transmission will be low due to the applied load at the end of the coil spring, the weight added. And if we see the applied force versus deflection for two types of pressure plate assembly, this one is the force and this one is the deflection. If you see the force and the deflection graph for this red graph will shows you the diaphragm spring at different condition when position when worn pressure plate, worn friction disc, position when fully engaged, position when a maximum or at maximum pedal travel. If you see here the diaphragm spring type, it will have, or the graph will be shows as the curve, and the curve, it seems wave. Sometimes it will go up and down, which means the force will be vary depending on the deflection rate. But if you consider the dotted, which is the coil spring type, it will increase proportional with the applied force. That means when the applied force increases, the deflection also increase. That means they will transmit too much force. So that's why this one is preferable. Initially, it will have high. Here, if you observe, for example, this point, the position when the clutch disc is wear, it will almost transmit about the maximum power transmission force. But if you consider the coil spring type, it will reduce by this much. That means when the disc is worn out, there will be some extra clearance, and that extra clearance will release or expand the coil spring, or the coil spring torque transmission ability will be lower. If we see in different aspects, in pedal force or required pedal force from the driver, for example, this one will be the foot force in Newton, and this one will be the pedal travel. If you consider this point, the diaphragm will be the blue, and the red one will be the coil spring. That means if the foot pedal or the driver applies too much force, you see the force required from the driver will increase proportional to the pedal travel. But in the case of diaphragm spring type, it will higher and later it will reduce. This is due to this shape. If you see, initially it is higher because initially the diaphragm spring was stored too much energy, and when the pedal depress, when it will become flat, the force will be reduced, and then again it will dish out. So at this condition, the force will be lower required from the driver. That's why they are applicable in light duty vehicle by means of some torque or force multiplication mechanism. When you see the remaining clutch parts, release bearing or throwout bearing, which allows the relative motion between the fork and the pressure plate assembly, and the pilot bearing, which helps to support the input shaft from which come from the transmission, because it's supported on the crankshaft, or in some case the flywheel by means of bushing or pilot bearing. And they will have clutch forks and wheel housing. Let's see this one in real location. This one is the engine crankshaft, and this one is the pilot bearing we will obtain from sometimes in the flywheel and the crankshaft part. And this pilot bearing supports this input shaft, if you observe. So this smooth part will be supported by this pilot bearing. So we need to check by during the inspection or overhauling time. We need to inspect because it will have too much friction, and if there is failure on bushing on pilot bearing, we need to replace this one. Again, if you see the wheel housing, this one is the clutch cover or wheel housing, which covers all parts, and the fork and the throwout bearing will be together because this is one release mechanism. So to release the clutch pedal, the driver, when the driver press this one, the throwout bearing must be depressed the diaphragm spring to make a flat and to pull this side backward to create clearance between the flywheel and the pressure plate assembly. That's why if it doesn't have any bearing, because this part is stationary and this movable, if we use some sliding friction, it will have impact on wear of parts, so that's why it uses throughout bearing. In the next part, we will try to see the clutch release mechanism. We will have mechanical and hydraulic operated clutch release mechanism. It comes from by means of, if you observe this one, simply this is hydraulic. It will have the pedal and the hydraulic system, and this will have mechanical. To make clear this one, it's better to see one animation here. So it's in Korean, so no problem. If you observe, the power is transmitted from the engine, and the mechanical and the hydraulic release mechanism is come from when the driver depresses the clutch pedal, the cable will transmit power to depress or to dish in or to move back this plate. So when shifting, look, you see, first depress, it's backward. That means the release mechanism is this one. And if we see the hydraulic type, it uses hydraulic fluid instead of cable. So in this part, if you observe, it uses hydraulic. Let me show you. For example, when you depress this one, you see the hydraulic fluid pass through and apply. They perform the same task, but the power transmission mechanism in that case is mechanical by means of cable, and in this case hydraulic by means of hydraulic fluid. That is the only difference in between. And in the next part, we will try to see the clutch efficiency and their limiting factors. When you see this part, it's better to see in one up, because we will have three critical things. These three critical things come from, let's consider one thing. For example, let's consider this one, a schematic diagram for the clutch. This one will be the vehicle wheel, and this one will be the engine. So always this clutch will transfer the torque of this engine to the wheel. That means there is some load here, and if this clutch disc will not have ability to transfer this torque to this load, what happened? There will be slippage. That means this part will be slip, or this part cannot be create better clamping force. So to have a smooth engagement or to have a smooth power transmission without any slippage, there will be some factors we need to consider when you construct the clutch. These factors are, look, the first one, the effective radius of the frictional surface. That means if you see this one, the effective radius means this lining part, or in this part, if you consider this one, this means R2 minus R1 here. So the distance from here to this, that means the distance from this lining surface. If we increase this lining surface, the frictional area will be increased, and the amount of force transfer will be high. The coefficient of friction acting between the frictional surface, that means the coefficient of friction, which will be the material we use, the surface part we use, will matter, this one. And if we use high coefficient of friction material, we can transfer too much torque, and the probability of slippage will be lower. And the next one, number of frictional surface. For example, if I make 1 disc, 2, 3, it will increase the amount of frictional surface. And the other one which relates with the pressure plate assembly is the applying force or the clamping force. Even if it will have better friction, if the clamping force here is lower, which will be reduced the amount of torque transfer from the engine to the transmission, and there will be slippage. When we come to the classification of this clutch, we will have mechanical, pneumatic, hydraulic, and electromagnetic clutch. Specifically, we will try to see about the mechanical clutch. This part will be applicable in different area. When we come to the mechanical, we will have positive contact clutch and frictional clutch. This positive contact clutch, sometimes we call jaw clutch and tooth clutch. Mostly they are applicable in gearbox parts. For direct drive application, for example, they use this. For slide mesh gearbox, they use this clutch mechanism. And frictional clutch, the disc type, cone type, and centrifugal type. Again, this disc type will be classified into two, single and multiple clutch, and sometimes they can work on dry and wet frictional surface area. Let's see one by one. When we come to based on the contact, we call positive contact clutch. This positive contact clutch will transmit power by means of what? The shape. If you see this one, it will have slot and it will have positive. So if we insert this part to this slot, which means the clutch will be engaged, and if we remove this part, or if this part is moved backward, the clutch will be disengaged. So we call this one jaw or teeth type clutch or positive clutch. Again, we have different types. Mostly they are applicable in parts which engage or disengage after the machine or the system is off. The next one is frictional clutch. This frictional clutch is work under between the friction between two parts. That means there will diameter 1 and diameter 2. Maybe this diameter 1 is rotary and the diameter 2 is stationary. So what happened here is we will create some frictional lining in between. In this frictional lining, when we press D2 against D1, balls can rotate together. When we separate balls, the power will be intermittent, because the target of this clutch system is to transmit power intermittently, which means to engage and to disengage the power which comes from this part. Another type is by another application. We will have, based on application of force, we will have push type clutch and pull type clutch. It will matters with, for example, in some case, if you observe this one, this type of clutch, this is when we pull this one, the clutch will be disengaged, and naturally it will push, and initially it will push and it will engage totally. When we come to the push type clutch assembly, this one will be, when we push this one will be back, because the pivot point is already here. So if the pivot point is here, if I apply some force here, it will go in this direction and this will come in opposite. So we call this one push type for disengagement, and this one will be for disengagement because the pivot point is here. When I pull this one in this direction, it will pull. So we have both type, the push type and pull type clutch, according to the force application. Based on number of frictional plates, if you observe, we will have single and multiple. That means here it uses single clutch disc or friction disc. If you observe this part, it uses 1, 2, 3 clutch disc, and it uses some intermediate plate. That means the force transmission ability will be multiplied by 3, because the total frictional surface area will be the summation of all these 3 plates and faces. So that's why they are applicable in heavy duty machinery, specifically these things. On the other hand, based on the usage of oil or use of oil, someone will be immersed in oil and some will be requires dry friction. For example, if you see this one, the clutch system we use for our vehicle it uses dry friction. If there is some oil, there will be slippage. And on the other hand, if we observe the wet type clutch, is applicable in motorbike, in automatic transmission. It immerses in oil because they are oil resistant material, because oil cannot reduce the probability of friction. That's why they can soak in oil and they can operate. The The remaining type of clutch is centrifugal type clutch. This centrifugal type clutch will operate by means of what? By means of centrifugal force. We call this one speed-based engaging clutch. This will have some frictional surface as you observe here, and this will have weights. It seems it shows the realistic, and this is the schematic one. When the speed of this shaft will increase, both this red part and the green part will be connected. So at this time the power comes from this shaft, or the interior part will transfer to the outer part of the drum by means of centrifugal force. So we can use this one if we use speed-based engagement on different application. On the other hand, we will have also conical clutch. When we come to the summary of this course, clutch disc can be solid or cushion drive, and for the clamping force for pressure plate assembly, they use some spring, and for coil spring type they use coil spring, and for the diaphragm spring type they use diaphragm spring force. And this clutch release mechanism may be used hydraulic or mechanical linkage to transfer driver's effort and to disengage the clutch system. And this clutch can be classified by different parameters, like based on the contact, based on application of force, based on number of discs and usage of oil. So this is my today's lesson. Thank you for your attention. If you have any comments, suggestion, just you are welcome with this contact address. Have a nice time. Bye bye.